All right, these are notes for AP Stats 6.2b and c. Yesterday we did 6.2a. That was strictly talking about transforming variables. That's where we're changing the value of something, but we're staying singular. Like we're going to change the value of 32 degrees Celsius, and we're going to change it to Fahrenheit by transforming it. Today, now we're going to go to combining variables, and that's where we take two or more of something. We're going to go from singular to plural today. We're not going to just talk about one thing like we did yesterday, transforming the mean or transforming the standard deviation. That's what we did yesterday. Today, we're going to be combining things, taking two or more of something. All right. First example, there's 3 examples. I'm going to just quickly summarize. Example 10, if you read through it, it is about the amount of money spent on books for an El Dorado Community College student. And we've already found the average is $153 and the standard deviation is $32. Just a friendly reminder, make sure you know how to interpret the average and the standard deviation. And if you don't, make sure you ask. In the long run, we would expect an average standard deviation. On average, this is how much we're going to vary from the mean by, okay? Or the average distance observations are from the mean. Okay, moving on now. What it wants to know, it says on average, how much are we going to have to spend altogether, okay? So that's tuition, books, and fees, so the overall cost plus the books. When we're taking the average of 2 distributions, we're either going to find the sum of the 2 distributions, 2 or more distributions, or we're going to find the difference. I use the example of Mr. Jans's class average is 85%. My class average is 90%. On average, what's the difference between Mr. Jans and my class? 5 percentage points. So in that case, we subtracted Mr. Jans and my distribution. In this case, though, we're adding, okay, because it does ask for the sum, I believe. Or it just says for the total cost. So we're adding that, and it tells us we're adding. Literally, all I do when I average or subtract, I just take the averages that they give me, and I either add them together or I subtract them together. And again, we're just looking for the keywords. The big keyword for subtraction is you might see something like difference, or I'll show you another example here in a little bit. So I found the average of the 2 distributions, but now we need to find the standard deviation of the 2 distributions. And the standard deviation of the combined variables brings in the condition of independence. This is a big deal. Showing a condition is like showing your ID when you have to get on an airplane. You have to show your license. You have to take your shoes off before you go through the metal detector. This is a condition or they won't let you get on the plane. You have to show these things. Same thing here. We have a condition or we can't use the formula I'm about to give you. The standard deviation of the combined variables has a condition that the 2 or more variables that you're checking have to be independent of each other. And I'll show you how to check that in context. Here is the formula. So make sure that you write this down in your notes. The standard deviation of whether you're adding the distribution together or you're subtracting. So finding the sum of the books plus the total cost, or finding the difference between Mr. Jans and my class. Doesn't matter. You take the standard deviation of the first distribution and square it, the standard deviation of the second distribution and square it, and you add it together, and then you take the square root of the whole thing. Okay. So we checked books and tuition at El Dorado Community College are independent of each other. The standard deviation, it says in the problem, you can read above in your cutout, but it gives us the standard deviation of both. So the standard deviation of books is 32. We square it. The standard deviation of the total cost is 103. We square it, we add it together, and we take that square root. We get a total of 107.86. All right, moving on. Combining normal variables, the weights of certain apples. Okay, so, the big thing is I circled normal. Whenever you see normal, again, right away, click in your head, ZOMS. I'm talking about 1 apple, but I'm moving from singular to plural to 12 apples now. Okay, it does say the sum, so we know that we're going to be adding. Identify the variables. So x equals apple, that's our singular apple. We're now moving to 12 apples. Okay, so now we're not doing x plus y anymore. We're doing x plus x plus x 12 times. So to find our new mean, we could add up 9 12 times. So 9 for the first apple, plus 9 for the second apple, plus 9 for the third apple, and 9 is the average of 1 apple, 9 ounces. But a quicker way of doing that would just be taking 12 and multiplying it by 9 to get you 108. So this is 108 is describing the average of 12 apples together. Okay, the average weight. The new standard deviation is our second step. Okay, so first step, find your mean. Second step, find your new standard deviation. Make sure to check the condition of independence, which I did here. Weight of apples are independent. The standard deviation of one apple is 1.5. Okay, so now we have 12 of these. So we would take 1.5 squared plus 1.5 squared plus we have to do this 12 times. Well, it would just be easier. And again, what am I doing? I'm taking the standard deviation formula right here. The standard deviation of the first thing plus the standard deviation of the second thing. And I say 2 or more. So you could be combining many things. And in this case, it's 12 apples. Okay, so I took 1.5, I squared it, and then I multiplied it by 12. So I didn't have to do it 12 times. I take the square root of that and I get 5.196. Okay, when it says, what's the probability? That's your P word. That means you're finding, the probability, the percentage, the proportion. Those are all the same types of questions that we have had. I like to draw my curve. That's my insurance policy. I mark my mean, my standard deviation, and I marked 100. How did I know 100 was my observation? I go to the question there. Less than 100 ounces. I find my z-score, ZOMs. I then go to my table, figure out the proportion, or I do my normal CDF with a lower bound of being negative 999, an upper bound of being 100. An upper bound of being negative 1.54, the mean of being 0, and the standard deviation of 1. So the probability of the proportion of having 12 apples weigh 100 ounces or less is 0.0618. Okay, last question. This is a really long question, so I want you to just read it right now. Pause it and read. Let me just summarize it real quick. You have a bin of medium strawberries, a bin of large strawberries. It gives us the standard deviations and the means for the large right here. It gives us the standard deviation and the means for the mediums right here. I would write that down. I didn't in the notes, and I should have done that. I see the word normally distributed, so I know I'm going to have to use ZOMs at some point. And then I see this word greater. Okay, because we need to know, are we going to be doing adding or subtracting here? So we talked about what is that word greater here. We don't see the word sum. We don't see the word difference. So what are we going to do? Well, to figure out if something's greater, we're going to use subtraction. For example, my husband's taller than me. How do I know? I take his height, I subtract my height, and we get, a positive number. That's how much taller my husband is than I am. So we want to know, what is the probability that the medium strawberry will have a greater? Again, my husband's height minus my height, that's going to tell me how much taller my husband is than me. Okay. We want to know in this case, so what's the probability that the medium is bigger? So we're going to talk more about that here later. We identified our variables. We have a large bin and a medium bin of strawberries. We know that the average of large strawberries is 6.1, and then the average for medium is 4.8. It says that here in the problem. We subtract them, again, because we've already defined that we're finding the difference. And we talked a lot about, think about if you're using addition or subtraction. So step 1, find your new mean. Step 2, find that standard deviation, check the conditions. Heights of strawberries are independent. So I take the standard deviation of the large, which says it up here, 1.2 squared. I take the standard deviation of 1.6 of the medium. I square both of them, I add them up, and I take the square root to get 2. Next, I need to draw the curve. Okay, so I have my standard deviation, 1.3 there in the center. The mean of 1.3, the standard deviation of 2. And then I talk about this curve. And this curve is describing the distribution of large strawberries minus medium strawberries. But the question isn't giving us an observation like it did here. Here it gave us that observation of 100. So we knew that 100 had to go right here for the curve. Now we have to think about, where do I need to put that line? Okay, so we really talked a lot about this in class. I'm not going to go as in depth. But we talked about, what does it mean if we want to figure out that the probability of the medium strawberry is bigger than the large? Well, if the medium is bigger than the large and I do subtraction, I'm going to get a negative number. So I want to find the probability of, when I subtract, of getting a negative number. Again, if that went over your head, rewind, listen to it again. This medium has to be bigger than the large. So I need a negative difference, okay? A negative difference, because again, this distribution is talking about the difference, okay? Well, where am I going to get a negative difference? Well, I did my line over here because 1.3 is a positive difference. On average, I'm going to get a positive difference. The large is going to be bigger than the medium on average by 1.3 centimeters. Okay, now a negative difference is going to be over here. Well, how do I know where to mark it? I need to mark it at 0. 0 is where they're going to be equal. If I figure out the probability that the observation is less than 0, those are my negative differences. This area is all where the medium is going to be bigger. Okay, the bell's ringing, so I'm going to quick finish up. I need to find my z-score then, 0 minus 1.3 divided by 2. I then go to the table, okay, or I do my normal CDF and I get 0.2578. Make sure you're practicing a lot with that table or that calculator. And then finally, what does this mean? It means 25.78% of strawberries in the medium basket will be large, or 25.78% of the time. Excuse me, I spoke incorrectly. 25.78% of the time, you are going to get a medium strawberry that will be larger than the large strawberry, or taller than the large strawberry. All right, again, any questions, let me know, and I hope you guys are all having a great day. Smile lots, people.